Flack math! Give me some math and I'll give you some flack. Flack math!
So we are going to graph linear equations. What are linear equations again?
Any equations that do like graphs and stuff because it makes a line.
Yep, that's exactly what it is. They're equations that when you graph it, it's a straight line that goes on forever in both directions. Because that's what a line is, right? A line segment stops, an array stops at one side, but a line goes on forever in both directions. And the reason for that is because when you have a linear equation, there are infinite solutions, okay? It's not just any random numbers, but they're infinite ordered pairs. So like this x goes with this y, but this x goes with this y, this x goes with this y. So there's infinite x's and infinite y's. So let's start with some examples. And this is one of the key concepts in Algebra 1 that you need to take with you to geometry and Algebra 2. Graphing a line is very important, okay? So this matters a lot. Not that the other lessons don't, but. So a linear equation, a graphical representation of first degree equation with two unknowns is a straight line. We talked about that. So for example, if I have this equation, y minus 2x plus 1 equals 0, okay? Well, first of all, whenever you have variables on both sides, it's hard to think of solutions that would work. I mean, I try to think of an XY combination that would make this work. I mean, you can. So if like X was 1 and then Y was 1, then it'd be 1 minus 2, which is negative 1 plus 1. So 1 comma 1, if X is 1 and Y is 1, that would be true. Do you see that? So if X is 1, that would make this 2. And then if Y was 1, it'd be 1 minus 2 plus 1 equals 0. That works, okay? Another solution could be if Y was 2 and X was 2. So it'd be 2 minus 4. No, X would have to be, let's see, Y was 3. If Y was 3 and X was 2, then it'd be 3 minus 4 plus 1 equals 0. That would work. So see how it's a little difficult to try to figure this out with both variables on both sides. But this is what would make it easier. So we're going to rearrange this equation. And this is a concept we're going to talk about in another lesson. But I want to do this first just because I want you to start getting into the habit of doing this. Get y by itself. When y is by itself, it's a lot easier to pick points that would work. So how do you get y by itself? I think we did one of these on the last test that's due tonight. So what you have to move everything over on that side, right? Well, what's the shortcut? When I move this minus 2x over here, what does it become? The 2x. So really, to get rid of minus 2x, you have to add 2x to both sides, right? But the shortcut is just when you bring a term over to the other side, you just negate the term. So this is a 2x over here, and then this is a negative 1 over there, right? So then I get y equals 2x and negative 1. So this is the same equation as this. This is just a lot easier. Now we can pick some xy values. So I think the easiest x to pick is 0. The next easiest is probably 1, depending on the equation. So when x is 0, what does that make y? If you plug in 0 for x, what does that make y? Negative 1? Is that what you said? You're right. So if x is 0, then it's y equals 2 times 0 minus 1, right? So now you have to figure out what y goes with that x, which is 0. So it's y equals 0 minus 1. So y equals negative 1. So that's what I'm going to do in my head to get the rest of these. Thank you. Okay, so I'm going to put a -1 there. What about when y is 1? When x is 1, can you do that in your head? When x is 1, what does y end up being? When you plug in 1 for x, what is y? 1, because 2 times 1 is 2, minus 1 is 1. All right, what about when x is 2? When you plug in 2 for x, what did you get? 3. Good. What about when x is 3? 2 times 3 is 6, minus 1 is 5. See how you just throw it in there and it spits out your solution? It's kind of like the nuggetizer, right? When you just plug it in and it spits it out what you want, it's nice. I'm sorry, Cheyenne. I thought you almost had that out of your mind completely, and then I reminded you again. I'm so sorry. Okay. So now these are ordered pairs, right? Guess what kind of shape this is going to make? A perfect straight line. Not perfect because this is not a perfect graph. Just a sketch here. But let's see what happens. 0, -1 is right there, right? 1, 1 is over 1 up 1. 2, 3 over 2 up 3. 3, 5 over 3 up 5. Right there. Look at that. Isn't that cool? It's not perfect because it's not a perfect graph, but if it doesn't form a straight line, then something went wrong. Okay, this is a great way to check. You could have just plugged in a number wrong, or you could have graphed it wrong, but something went wrong if it doesn't make a straight line. Now, technically, all you need is 2 points, right? All you need are 2 points. But having more points says, okay, I must be doing it right because they're all making a straight line. If you just have 2 points, that's always going to form a straight line, right? So pick at least 3 because you have one safety one to say, all right, obviously you can make a straight line out of 2, but since that third one is in that same line, then I must be doing things right, okay? All right, so that is basically the gist of today. You're going to graph. For your homework, you're going to graph linear equations. So let's try another example, and let's see if you can just sketch it. It doesn't have to be perfect, but if you have graph paper, that makes it a lot easier. And on your graph paper, like you know how you have graph paper like this? Okay, when you draw your XY axis like this, don't do this. Don't go boop, 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 boop. I know it takes up less space, but use the lines 1 unit per line. Don't say, okay, each line is 2 units. Don't do that. All right? This is 1, this is 2, this is 3, and so on. It's going to be a lot easier, and it's a lot less confusing, a lot less stressful. You're going to save years of your life because you're not going to be stressed in 9th grade math. Okay, so let's graph another line here. Let's see. Let's try this one. Let's graph this equation. Y equals -1/2 x plus 2. Okay, what's the first thing you do? Remember the first thing we did over here in the first example?
We got the variable by itself.
Yeah, so it's already by itself, so we don't have to do this. Now we've got this situation. Now what do we do? Yeah, you can start thinking of some x's. Now, I said like 0, 1, 2, 3 in this one. Are those some good choices for x? We can try that. Doesn't matter. But 0 is always the best, right? So let's try 0 for x. When 0 is for x, what is y? I think I heard it. 2, right. When you have 0 for x, it basically drops a bomb on this whole term because 0 makes everything cancel out, right? So what are you left with? A 2. That's nice. So you have 0 plus 2. So y has to be 2 for that equation to be true. All right, now you could do this if you want, but what's 1/2 of 1? When you multiply negative 1/2 times 1, that's kind of uncomfortable. So what's a good strategy? Yeah, pick some even numbers because you can cut those in half. 1's not bad. It just makes it a little bit more confusing. There's nothing wrong with that. Just you can, but when you graph it, it's a little more difficult. So I'm going to pick some even numbers. So 2 and 4. Okay. So let's plug this in. We might have to write this one out. Y equals negative 1/2 times 2 plus 2. So what's y going to be? Can you do that in your head? You got it, Nathan?
Will it be 1?
Yeah, because what's negative 1/2 times 2? Well, what's 1/2 of 2? 1. So negative 1/2 of 2 would be negative 1 added to a positive 2. Negative 1 plus positive 2 is positive 1. All right, what about when x equals 4? Yes. Negative 1/2 times 4 is negative 2 plus positive 2 cancels out to 0. So let's graph it. 0, 2, to the left or right 0 and up 2. Boom. 2, 1 over 2 up 1. 4, 0 over 4 up 0. And you're done. That's not too bad, is it? Can you guys handle that? Okay. Let's do, there's a couple special cases. You might get one of these in your homework or on your next test. Let's do 2 more examples. Let's graph this. Graph y equals negative x. Okay, yes, this is as easy as it looks. So let's pick some x's and see what y's we get. Pick it, what are some good x's? 0. When x is 0, what's y? 0. Not negative 0, but just 0 because there's no. So when x is 1, what's y? Negative 1. All you're doing is negating it. 2, negative 2, 3, negative 3. So when I graph this, it's 0, 0, and then over 1, down 1, over 2, down 2, over 3, down 3. So it looks like that. Okay? All right, here's another one. Let's graph this. So if I made an XY chart here and said x is negative 2, what's y? Well, it could be anything. You could choose anything for y, but x will always be negative 2. So y doesn't change it. That might be a little tough to explain, but when I graphed this before, like on a number line, it was like right there, right? So back in the day when remember when we did inequalities, but when we just said graph this on a number line, then you just put a dot on negative 2. Remember doing that years ago? Okay, well, this is a 2-dimensional plane now. So that means you need to graph everywhere where x equals negative 2. So this is going to look like this. This line is going to be a vertical line that goes all the way up to infinity and all the way down to infinity. Okay? So x equals negative 2 everywhere on that line. So that's a little bit, that kind of messes with your head a little bit. But here's the deal. When you see x equals anything, it's just a vertical line, straight up and down. So when x equals 10, it's a vertical line where x is equals to 10, okay? So what if it was just y equals something? What about y equals 4? Yeah, it's just a horizontal line, right at y equals 4. Okay, which is kind of opposite of what you think, because when I think of x, I think of the x-axis, which is that horizontal line. When I think of y, I think of the y-axis, which is a vertical line. But That's not true. When y equals something, it is a horizontal line, flat. When x equals something, it's a vertical line, okay? Those are some special situations. Don't stress too much about those. All it is a checking your solutions manual and oh, okay. Yeah, that's right. Forgot. You do a few of those and then you won't forget. All right, that is lesson 51. Let's do lesson 52. Okay, so we're going to do more addition of rational expressions. Okay, so we're going to add more rational expressions. And then we're going to do some other stuff here. But let's do a little bit of review. Let's see, I have 2 over a plus 3 over b. So we can't add these, right? Because they're not the same denominator. So how do you make the denominators the same? What do you do? Yeah, you just squish them together. When they're not the same, when they don't have anything in common, you just squish them together. So my common denominator is going to be AB, right? So if I multiply the bottom by B, I have to multiply the top by B, right? So there's my new numerator for that one. So this is I need an A to make that an AB. So that's 3A on top. Does that make sense? Okay, so your answer is going to be 2B plus 3A. Now that you have the same denominator, you can add the numerators. And that's it. Remember doing that? And that's on the test today too. It's almost as easy as this. The one on the test is almost as easy as this one. Okay, but we're going to do something a little different, not too difficult. It's the same concept, but it looks more difficult, but it's not more difficult. Okay? So here's example 1. If I have a over x plus b over x plus y. Now here's the deal. It kind of looks like they both have an x in common, doesn't it? So can I just add y to here and then add y to there? That's like my first knee-jerk reaction. I have to make these denominators look the same. Well, to look the same, I can just add y, right? But that's not the rule for equivalent fractions. The only thing you can do with fractions is multiply or divide the top and bottom, okay? That's the only thing you can do. Because, like, think about it. You can't just add 1 to the denominator and add 1 to the numerator. Is 3/4 the same thing as 4/5? No. So you can't add the same to the denominator as you do. So it's only multiplication. So unfortunately, these two have nothing in common. Or a better way to put it is these have no factors in common. Remember, factors are multiplied. So x and x plus y are completely different. So these are completely different. So what did we do with those denominators? We just multiplied them together. So that's what we're going to do here. Look at this. So this one needs an x plus y. So the top needs an x plus y. And this one just needs an x. Okay, did I do anything wrong? I use multiplication. That's really the only rule for equivalent fractions is it's limited to multiplication and division. So I just multiplied the bottom and I multiplied the top by the same thing. So I multiplied this bottom and the top by the same thing. So it's okay. Now I have the same denominator. I add across and I get a x plus y plus bx all over x times x plus y. And that's really all you can do. Okay, so see how it looks confusing because there's more, you have to write more, but it's really the same thing we did up here. So this is kind of like putting a B on the top and bottom. This is just a chubby B, okay? So see how it's still like A, B, whatever. I just put here what this guy didn't have, but this did. And so now they both are the same. So it's the same kind of concept. It's the same concept, exactly. But it just looks different because you have to write more, okay? Let's try another one. Okay, let's walk through this together. 4x plus a over a plus b plus c over x. Okay, how do we make these denominators look the same? Okay, so what does this guy need and what does this guy need? So Xander, what does this need? It needs an x. So I'm going to put an x. And remember, I have to multiply the whole thing by x, so this needs parentheses. So I'm just going to put an x here, and then I'm going to put an x there. So remember, that has to be multiplied by the whole thing, so parentheses are always better, okay? All right, Cheyenne, what does this guy need to make it look like that?
Parentheses A plus B.
Perfect. Parentheses a plus b. So this one needs a parenthesis a plus b. So when you're trying to figure out the denominators, try to ignore the numerators completely. These numerators have nothing to do with what your common denominator is. So you only have to decide that. And then now these will get the results. These will be affected by what you multiply by the denominator. But these have nothing to do with how you determine your common denominator. Okay? All right, so now we've got this situation, so we can just add across. So x times 4x plus a plus c times a plus b, all over that same denominator, x times a plus b. All right, so I think you can stop here, but is this simplified? Now, what's the enemy of simplifying? Parentheses. Remember, 2 steps of simplifying. You're looking for parentheses and you're looking for like terms. Well, the only reason some people just, you can leave it like this because the main reason for getting rid of parentheses is to see if you have like terms. But you won't. But if you write it like this, that's totally fine to just multiply it out. And you can do the same with the denominator too. So what is that? 4x squared plus ax plus ac plus bc all over ax plus bx. Okay, so you can write it out like that, multiply it out, get rid of the parentheses. Now you feel a little bit more simple because the parentheses are gone. So you can leave it like that or like this, okay? All right. Couple more examples and then we'll move on to the next concept in this lesson. So let's try this on your own. See if you can get a common denominator first, and then we will simplify it together. A plus b over x plus c over m plus d. All right, see if you can add those together. So you need a common denominator, and then once you have that, we can add it together. Please enjoy this music while you are doing your work. Sounds good. Cello. Rocking that cello. Okay, what'd you get for a common denominator? Don't be shy.
I got MX.
All right, what'd you get, Nathan?
Xn.
Yeah, same thing. So XM or MX. So this one needs an M, right? And what is this? And so I need this to be an M too, so I'm going to put parentheses. Do you see how if you don't put parentheses, you're only multiplying the M times the A, right? So the whole numerator needs to be multiplied by M since the whole denominator did. Okay, what does the second fraction need? An X. We'll put an X there. All right, what about the third fraction? What does that one need? What? Yeah, both of them. Because this is over 1. So how do you turn that 1 into an MX? Multiply by MX. So this is like that. So really, you can just do that, and you're good, right? So whole numbers are nice because all you do is throw the common denominator on the bottom and on top, and you're good. Okay? All right, so let's add them together. What'd you get? Should we simplify those parentheses at the same time? Let's do that. What is that? AM or MA plus BM plus CX plus DMX all over MX. And it looks messy, but the whole point of this exercise is to turn 3 fractions into 1. And we did. It's an ugly fraction. It doesn't look like we made anything better, right? But we accomplished the goal of adding these fractions together to make one ugly fraction. Okay? That's it. I have one more example. Okay, I have one more example, and I think it's worth doing because it's a little crazy. So this is as complicated as it will ever get, this last example here. There's lots of things that will potentially throw you off in this next problem. So if you can understand this, then you are in good shape. Or if you understand it after I explain it, you're still in good shape. Because this is a tough one, okay?
Can it be a free problem without one?
Sure. So, but I'm not going to give you too much time. So let's see if you can do this on your own. A over B plus C minus X plus D plus M all over K. It looks pretty harmless, doesn't it? Once you get into it, there's some potentially confusing things. So, but I believe in you. I believe you can do it. Take a couple more minutes. Okay. One little thing you need to do.
Are we supposed to simplify it?
Good question. You can leave them in parentheses. Oh, we will eventually simplify it. We can do that together, but for the free problem set, you don't have to simplify it. Oh, you simplified it. Okay.
I feel like that was too easy. Like it's
Yeah, so there's, before you simplify, is this before you simplify? Okay. So there's a couple things that you left out. Why don't you think you're right? Well, you're right. Good job.
The right answer. Looks like a bunch of random gibberish to
I know, it doesn't feel like you're getting it right.
I think I can work on it.
There's just one little thing that you were missing, Nathan. So if you can figure that out. Figure it out. Figure it out. Okay. Okay, so there's you're missing one thing there and some symbols there. All right, do you get an answer, Cheyenne?
Yeah, don't judge it, please.
Don't judge it. Well, that's my job.
Okay, listen, I tried.
You did. We got the right common denominator. And then this is, and we'll clean that up. All right, here we go. So, common denominator looks like just this squished with that, right? So we need a K over here. And this one needs a B plus C. Okay, and this is what Ryona, you, and Nathan forgot. You need those parentheses. Because without those parentheses, see how it's just M times B plus C? So you can't forget those. But this one needs everything. So this one needs a K and a B plus C. So some of you forgot the K in that middle
I
one.
thought I was wrong. It just felt weird.
It does feel weird. So now when I simplify it, I get AK plus, let's just do that. I get BKX plus CKX. All right, and then when you simplify this, did you simplify this, Audrey?
No, but would it be AK minus AK?
Oh, yes, good
I was
job.
thinking, or the because I just left the negative in front of the X.
So minus, so both of them are subtracted, right? So that's another free problem set for. Yeah, they're both subtracted because you're subtracting the whole thing, right? So this, you need to subtract both terms. Good job. Okay, and then look at this. How do you do that? This is a new concept. Do you remember the acronym? Starts with an F.
Foil.
Foil. We're going to FOIL that out. So then we get, let's see here, D or BD plus CD plus BM plus CM all over K over B plus C. Okay, so simplifying doesn't look any simpler, does it? Actually, more stuff is on the board. So generally, the rule for simplifying is to write it with as least amount of ink as possible. That's not really the case here, but that's okay. All right, so moving on, we're just going to talk briefly about overall average. This is a typical Saxon move. Just throw in this concept, which has nothing to do with what we've been talking about, but it's good to keep this kind of, this is life applicable math here. So overall average. So I calculate overall average when I calculate your grade, right? So I don't look at your individual scores. Well, actually, I don't do anything. My grade book does the calculations, but I don't need to know your individual scores because I take your homework grade, I take your participation grade, and I take your test grade. And your homework grade is worth 30%, your test grade is worth 60%, and your participation is 10%. So I take your homework grade and I multiply it by 30. Because it's kind of like adding your homework grade 30 times. So that's what it's like a weighted average because some of these averages have weight and others don't. Okay. So what I wouldn't do is just add your homework grade, test grade, and participation grade, and then divide by 3. Right? That's not fair. Because your test grade is worth more than your homework grade, and your homework grade is worth more than your participation grade. So I can't just add them up and divide by 3. If they were all worth the same, then yes, I could. But I can't. So I have to weight your test grade by multiplying it by 60. And then I have to weight your homework grade by multiplying it by 30. And then I have to weight your participation grade by multiplying it by 10. And then what do I divide by? Because how many grades are there? Well, there's 60 of your test grade. There's 30 of your homework and 10 of your participation. So how many grades are those? 100. So you add them all or multiply it by the weight, add them all up and divide by 100. Okay, so that's kind of like what we're doing today. But instead of a weighted average, it's overall average. Okay, so let's just do an example. Average of the first 6 numbers is 8. So I don't even know what those 6 numbers are, but I do know that the first 6 numbers, the average is 8. The average of the next 10 of next 4, sorry, is 10. Okay? So how do I calculate this overall average? I don't even know any of the numbers.
Can you just do 6 8s and 4 10s?
Yes, you can, because the average of 6 8s is also 8. But either way, remember, if you know the average of 6 numbers, then you know the sum of the numbers. You just multiply the average times how many numbers. Okay? So, and then how many numbers is that totally? So 6 8s, so 6 times 8, plus 4 10s. And how many numbers is that? There's 6 8s and 4 10s. How many numbers is that? 10. Then divide by 10. So 48 plus 40 is 88. Divided by 10 is 8.8. Okay? So really, the formula is right in the problem. Average of first 6 numbers is 8. Average of next 4 numbers is 10. 6 times 8 plus 4 times 10, all divided by 6 plus 4, which is 10. Okay, try another one. Ready? Here's example 5 in this lesson. It's example 5 because we did all these. So let's say the average of 90 numbers is 4. The average, that's a lot of numbers. Average of next 10 numbers. So how many numbers total? 100. Is 6. What's the overall average? So see if you can figure that out. I don't think you need a calculator. I think you can do this in your head because you're dividing by 100. That's easy. Okay. Did you get it? What'd you get?
42.
42? Well, it looks like,
4.2.
yeah, so you just one more decimal because then you can look at, okay, the average was 4 and 6. Oh, so it's got to be between 4 and 6. It's not in the middle. It's way closer to 4 because there's 90 4s and 10 6s, right? So it's way closer to 4. So let's do that. So 90 times 4 plus 10 times 6, all divided by 90 plus 10, because there's 90 numbers and then 10 numbers, so 100 numbers. So let's see, that's 420 divided by 100, which is 4.2, which makes sense because it's got to be closer to 4, right? Because there's 90 4s and only 10 6s. So it's not going to be in the middle. It's not going to be closer to 6. It's going to be way closer to 4s because that's where most of the numbers are, okay? Does this feel okay? All right, good. That's it.
Black math, give me some math and I'll give you some flack. Black math.